Hi guys. Okay, so basically I've been waiting on my mom here in a store. I actually dropped her off actually and waiting inside the car. And I decided I'd make a YouTube video to explain CPU cores for those of you who don't understand what CPU cores are. Especially when you're buying a laptop or a computer, the CPU does reflect in terms of the price of a laptop. So sometimes you might say, well, this laptop, the price real good. But when you're really checking it, the CPU may be, a low quality CPU or a single core CPU. And this is what I'm about to explain. So essentially, let's go way back. Initially, when the CPU was created or the idea of a computer was created, it was kind of like think about like a calculator. A calculator could only do basically one task at a time, which is to add or multiply or whatever is the case, right? Um, so essentially, that is how a CPU worked. A CPU would only allow you to do a single calculation at any one specific time. Now, as CPUs progressed, the speed at which the CPUs increased. So, for example, long ago, it was not unpopular to have something like a 33 megahertz CPU, and nowadays, well, let's so then even to talk about nowadays. Let's just talk about how it increased. So from 33 megahertz, they came up with a 50 megahertz, then 100 megahertz, and back then that was like so awesome. That was like really fast in those days. And as it progressed, 100 megahertz turned into 500 megahertz and into 1000 megahertz. Now, when the CPUs progressed into the point of 1000 megahertz, they started to call it a 1.0 gigahertz CPU, which is 1000 megahertz is 1 gigahertz, right? So essentially, um, this also increased. So you ended up not now, but not even recently, about like 5 years ago, I would assume, about the 2.0 gigahertz single core CPUs. Now, as I said, the CPU single core means it's one core, one CPU. Just consider it like that, right? At least for the time being. And it basically meant that you can do um, tasks. What you could do is you could do tasks like a calculation. Think of the calculator again. So 1 plus 1 equal 2. You could do that task, which is a single task, but do it faster, allowing you to do much more singular tasks in the same period of time or less period of time than when you had like a 200 megahertz CPU. Um, so let's put this into perspective again, because I probably get it a little complicated. So long ago, let's say that you had a task. You had a task to um, multiply 10 by 10 to give you 100, right? Let's say that CPU was a 30 megahertz CPU. That might have taken about 1 second to calculate. I mean, this is an arbitrary value. 1 second to calculate on a slow CPU. Then around um, then in the future, well, not in the future, not I mean, from the past to where it progressed, a 2 gigahertz CPU, which is like a 2000 megahertz CPU, would have been about at least 100 times faster, right? If the calculations are correct. So what would have taken 1 second would have now taken 100th of a second with a single core 2.0 gigahertz CPU. So that was great progression back in the computer world and the IT world back then. And then they started to create dual core and now quad core and now you know 8 core and hexa core and all those different things. Right, good. So the explanation now is that they packed basically, when one CPU was one CPU, now one physical CPU has two cores in it. So it really means that instead of it being able to do only one process at a time, it can actually do two parallel processes at the same point in time. Right, so what does that mean? It means basically that you could do two calculations simultaneously. So 10 by 10 would be simultaneous, 10 by 10, which would give you 100. You could calculate that at the same time while calculating 20 by 20, which is 400. What this would allow you to do is essentially be able to, it's more real in terms of multitasking. Now, not to go into too much details with operating systems and how operating systems work. But essentially, the computer creates the illusion. When there was a single core CPU, the computer creates the illusion that everything is working simultaneously, but it is not. And I will get to, I'll create another video to explain what I mean by that. But essentially, now as you have the dual core, which is two CPUs, that is like twice the speed now, because like you would have one, if you had one single core CPU at 2.0 gigahertz, now you have a dual core CPU which has, each core has 2.0 gigahertz. This would allow you to basically have 4.0 gigahertz, 2.0 gigahertz by 2, because it's two cores. So you would have 4 gigahertz, so that's like twice the amount, right? And then what they started to do too was then they started to create quad core. Now the quad core allows you 4 cores, so that means that 4 parallel processes can happen, and that is even better because the performance should increase as long as the coding, as long as the programs allow you to use the quad core. So when they created the quad core, um, in essence, that allowed 4 processes at the same time. So 10 by 10 could be calculated at the same time as 20 by 20, which could be calculated at the same time as 30 by 30, calculated at the same time as 40 by 40, and then return the values. So essentially now you would notice that a quad core might be 2.0 gigahertz on each core. So multiply that by 4 and you would see that you actually have 8 gigahertz, which is nearly twice the amount of a dual core, which is basically 4 times the amount of a single core. And then they created the 8 core CPUs, which is basically generally 2.0 gigahertz on each core, multiplied by 8, which is nearly 16 gigahertz. So 16 gigahertz is, you could understand in terms of the processing power, it's a serious increase in processing power. So what you would notice as well is that the single core CPUs will be, the prices will be a lot cheaper. So you should, that's why you might see a laptop deal and you might say, wow, how could this laptop be so cheap? And the first thing you need to check is to make sure that that CPU is a good CPU, because I can tell you for sure that limiting your CPU is basically limiting the lifetime of that computer, what the computer could really do. By having a single core CPU, you may be limited more to things like word processing, Excel, and maybe PowerPoint presentations. But if you were to go into the dual core and quad core processors, that would be more in the range of, you have to do graphic design, maybe programming and compiling, additional more calculations, more CPU intensive applications. So that would help you to decide if you really need to spend so much money on a dual core or quad core or hexa-core or 8 core as opposed to a single CPU. In my personal opinion, I would never use an Intel Celeron processor. The Celeron processors are low-end processors and they are really cheap, and I still see them selling on the market right now. I would not go there. I would say if you have to go with something, go with anything higher than a Celeron processor. I would recommend, if you are a basic average user, maybe a dual core. If you are going to do graphic design, maybe gaming, quad core and up. Now there's another thing that I want to explain, which is called threading. Now each core now, remember we were talking about the single core and the dual cores. Now what they started to do was create multi-threading cores. So it means now that instead of, for example, the dual core could have done 2 simultaneous calculations at the same time, but with the threading enhancements, they take each core, remember there's 2 cores on a dual core, and they take that single core, consider one of the cores on it, and they enhance the core so that it actually is able to do 2 threads at the same time, 2 calculations at the same time. Now that has also helped to create better processing for the average user, because by creating simultaneous threads, now the CPU or the application is able to, I think it would be able to handle better in terms of responsiveness as well. So I would say that at the end of the day, you look at it in terms of core. If you're not cores, if you're not too tech savvy, if you are tech savvy, you wanna have a little more threads. So the new age dual core, which is supposed to be 2 cores, allow you to run 4 threads, which is 4 simultaneous operations, which is great. It's kind of like having a quad core, but not having a quad core, if that makes any sense. So that I think dual core with 4 threads is pretty good for the average user. Um, for as I say, the more high end users go for the quad core or higher. The cost is going to be I mean, uh, it's going to be you will notice the cost is going to be more, right? So it's substantial. So I hope this helped to explain more about CPU cores and and please subscribe to my YouTube channel and I will see you guys soon. Thanks again. Bye.